today we're talking about net surface area and volume of cylinders. So we're going to introduce the concept of volume and surface area and net. So this all should be a review from middle school, 7th, 8th grade math. But it's been a while, so that's why we're reviewing it now. So these are nets. A net is a flattened out three-dimensional solid like a cube. So a cube is like a die or dice, right? When you cut out the net, fold it and glue it together, and you can see what the 3D dimensional shape looks like. And I did one for you. Just don't really think you're right there. So this looks similar to that net in example 1. That one is a cube. Mine is different. Mine's going to look like an Amazon box, a rectangular prism. Sometimes you'll get cubes, like when you get packages delivered, you get a cube as a box that all the sides are the same height and width, or height and length, right? So this is one big rectangle and two rectangles here, right? If I fold these rectangles together, this is actually the lateral area of this solid, or 3D. So we're talking about solids today. They're three-dimensional figures. This is a two-dimensional shape, right? Of length and width, we can find the perimeter of it, right? Yeah, so this looks a lot like that, right? So if you fold it, you see now it looks like a box, right? Exactly. So you go from a 2D flattening, you fold it up, and you create what we call depth, right? When you go to a 3D movie where there's glasses, you can see what we consider depth, because things look fuller, right? So this would be a rectangular prism. A cube is also a rectangular prism, but it's special, like all square things are. It's made of squares, right? So what shape do you think? Well, we're going to write cube next to that one. That one would be a cube, I think. I think that they intend for all those that the width and length to be the same. So this would be a cube, or a rectangular prism is another. Can't read my handwriting there. Rectangular prism. And dice would be an example that you might see in the real world, right? Anybody have an idea what this net folds up to? What would this fold up to, Tyron? A pyramid. So pyramids, all sides, well, there's such thing as a triangular pyramid, and then all faces are triangles. Most triangles are square pyramids, like this one is, so there's one square and all the faces are triangles. So if you can imagine this square in my hand and these triangles here that all fold up and meet at a vertex or a point at the top, that's a pyramid, right? So that would be a square pyramid. I can't draw that, but if you look on your homework, number 2. Any questions? The base is square. So you could have a rectangular prism, a pyramid, and that means the base will be rectangle and all the other sides will be triangles. Right? So you still have 4 triangles, but some triangles will be fatter than the others. So two fatter ones on opposite sides and 2 skinnier ones. You can have a triangular prism where the base is a triangle, right? So then all the sides will be triangles. But that one doesn't have to be the same size as all the sides. No, it doesn't. You could have a pentagonal pyramid, so the base is a pentagon, and then you have 5 triangles, right? So you have the same number of triangle faces or sides as you have sides in the base. You could have a octagonal pyramid that would have 8 triangular sides, and the base would be an octagon. Make sense? seventh grade math, a lot of kids were going to call example 3 a pyramid. Would you think example 3 is a pyramid, or why wouldn't you think it is? Yeah, it's got 3 rectangular sides, right? So all of these are rectangles, and it's got pairs of parallel triangles. So this is a triangular prism. So prisms are also named by the shape of their base, and the bases are these parallel opposite bases. The triangular prism, and it's made of 3 triangles. Use your imagination that these are the same, because that's what it looks like it is up there. Now, if this were a tall triangular prism, skinnier, a bit triangle at the bottom, and then they don't have to be the same size rectangles. It looks like this one is, so I'm trying to draw mine that way. But now we've got to put, so right now, I have this part, right? I have 3 rectangles. Does that make sense to everyone? So if I fold these 3 rectangles up, I have the lateral area, or the sides that are bases, of that triangular prism. Does that make sense? So now what I need is some triangles to fold up, a triangle to fold up, or a triangle to fold this way. It doesn't matter. As long as we have one on each side of our rectangle. So just to be consistent, I'm going to put a triangle there and a triangle there. So the only thing, it does not matter where you put these triangles as long as one is on each side. You can't have 2 there because these would cover the same spot. I mean, one is not covered. Does that make sense? Okay. Anybody know what this is called? Cylinder. Okay, it's a cylinder. Technically, we don't consider this a prism. You will see it described as a right circular prism right now. Technically, prisms are all flat surfaces, like a cube, a rectangular prism, a triangular prism. You can have a pentagonal prism or an octagonal prism. You know, anything that has all flat faces. Cylinder, we don't consider a prism normally, but you can, like I say, people call it a right circular prism. So a cylinder. So what is that? Rectangle. If I curve it around, I'm not really exactly folding it, but kind of. If I curve it around, it looks like a cylinder, right? So that curved surface of a cylinder, that's its lateral area. Now, if I had a circle right here, I could fold it up. If I had a circle in this rectangle right here, I could fold it up, and then I'd have a full cylinder. Does that make sense? So we're going to draw a rectangle and put a circle on each side, and that would be the neck of a cylinder. So we can put it here and here, we can put them both here, we can put them both in the middle, it doesn't matter, as long as there's one on each side. So look, are you keeping up with me? Okay. Cylinder. This is a cylinder. A cylinder has 2 parallel circular bases connected by a curved surface. You can see that you can have a short, fat one, you can have a long, skinny one. The bases are the circles. Typically think of bases as something that something sits on, like the base of a statue or the base of a trophy. But in these figures, the bases are the parallel faces, the parallel sides. So this is a circle here and a circle in the bottom that you can't see. The circle here, a circle on this other end that you can't see. Circle and circle. The circles are always the bases. The height is always the length or the distance between them. Okay? This is called a right cylinder. And it's called a right cylinder because the radius and that side are always a right angle, right? Here and here. And this is the height. The radius is the radius is the radius. It's from the center point of that base to the circle or the curved face. Curved surface, right? That's the radius if I can be using. The radius can be found, it's the same on either base for all the cylinders we're working. Well, 4 cylinders. Alright, this one doesn't look like the same I just explained. It looks like the Leaning Tower of Pisa. This is an oblique cylinder. So this is not the height. This is the height. It's the distance. So if this cylinder was standing on its base like this, how tall is it? You measured it from the ground perpendicularly. When we measure things, we don't measure them slanted from the ground, right? If I want to know how tall this bookshelf is, I don't stand out here and use the yardstick from here, right? I want to go from the floor up, right? Straight up perpendicularly. But not the height. That clear light is not the height. Even if it's like, so this is the height, right? And this would be the radius. This is the height. That would be the radius, right? So perspective is one thing. If we go from here to here, it would look shorter, but that's just perspective of this drawing, right? Following me? Okay. Lateral area. So, lateral area of a cylinder is this curved surface, right? If we're finding the lateral area, we want the area of that curved surface, right? It's actually just a rectangle. We don't know the length and width of this rectangle. What we can use is the circumference. So if you fold this, are you watching? For some reason I think this is particularly brilliant. If you fold this, the circumference of the circle is the length of that curved face, right? The circumference of that circle, which you can think of as the perimeter of that circle, is the length of that curved face. So, circumference times the height of the cylinder is the area of that lateral area. Does that make sense? So we're going to have a formula for that. But the lateral area is the area of a solid, not including its base or bases. So a triangle or a pyramid only has one base. But for all the things we're talking about, certainly for a cylinder right now, it's going to be that curved surface. Finding the area of the curved surface. The surface area of the whole thing is going to be the area of the curved surface plus the area of this circle on the end and the area of this circle on the other end. So curved surface plus this circle plus this circle. So the surface area is the sum of the area of all the faces of a solid. So in this case, technically, we would not call the curved surface a face. Typically, faces are flat sides, but I'm using it here. So if you have your reference sheet out like I asked you to get, you're going to see a section that says prism/cylinder. and it has surface area equals 2B plus CH, and V equals BH. So that is a formula for rectangular prism, triangular prism, or cylinder, or cube. Right? How can that be? Well, we modify these formulas based on the shape of the solid cases, rather. So for a cylinder, the lateral area is the perimeter of the base, the big D is the perimeter, stands for perimeter of the base, but in a cylinder, perimeter is actually circumference, right? Just got a circle. So the big D stands for the circumference of one base, of a base. So the distance around, and then the lateral area is the circumference of the base times the height of the cylinder. So we know the formula for the circumference of a circle, and we're going to use 2 pi r, right? The circumference of the base of a cylinder, the formula to find the circumference of a circle is 2 times pi times r, or pi d. Sorry? This is perimeter of the base. Big P stands for perimeter of the base. In this case, it's circumference because it's a circular base. And this is height of the cylinder, so it's these right here. Okay? So we're going to modify that formula based on the shape of our base, and we're going to say that is 2 pi r times the height. Surface area formula for any prism or cylinder, the surface area equals 2 times big B, and I'll remind you what big B is. Is that in your formula sheet? Yeah, so it tells you on there. So what you'll see on your sheet, it tells you that big B is area of base. But if you look, it tells you that big T is perimeter. You have to know it's the perimeter of the base, right? You have to know some things. It doesn't tell you everything on your formula sheet. So 2 times the area of base plus the perimeter of the base times the height. So 2 times the area of one of these circles plus the lateral area. So the formula we're going to use for the area of the base of this circle is pi, let's put area of the base in there. The area of the base, and that formula is, for a circular base, is pi r squared. And these are the bases. And this is the base. This is the base. So the formula for the surface area, once we've modified it for this particular solid, is 2 times the area of the base, which is pi r squared, plus perimeter of the base times the height. Well, perimeter of the base is 2 pi r, and times the height of the cylinder. So that's the formula we're going to use. We're finding the surface area of the entire solid. If we're finding just the lateral area, we just use the pH chart. Remember to get your calculator out. Once you get your get that written, clear your calculator 3 times and press the pi button. Press the pi button. Did you get this number here? So you have used pi before. We have substituted the pi. This is not even pi, right? Pi goes on forever and ever and ever. This is the most exact pi. That button is a more precise version of pi than we normally use. Normally we use 3.14, right? Another 7 or 22 ABC 7 equals. Right? This is a decimal. So notice these are not the same, but here to here, here to here, here to here, they're the same. All right? Unless they tell us differently, I wanted to use the pi button. I even taught the pi button in second period, but I had a discussion with Miss Rayleigh, and she says on the EOC, they don't use the pi button. So we're not going to use the pi button unless they tell you to do that on the EOC, then you would do that, right? We're going to use 3.14, but they will tell you that on the EOC as well. But for our purposes, unless they tell us differently, we are going to use just 3.14. It's not as precise, but that's what we're going to use. We use 3.14 for pi. Pi doesn't equal 3.14. We're approximating pi with 3.14. For our purposes, it's close enough. We're not calculating the amount of gas needed to get to the moon and make sure astronauts get home or anything. So we don't have to do that precise. You put your pencil down when you're done writing. I'll know you're done, and I'll see how to gauge where we are. It doesn't matter. I prefer fractions, but I just do it anyway. Hey, my guys that are taking the test, look at these directions on 6 and 7 on the back. You don't have it. Oh, it is kind of it. It says, use the graph to find the new coordinates of the reflection. Switch that to image. Start that make it image. Not a reflection. You're going to look at the notation here. What does that lowercase r mean to do? Don't tell me, okay? All right. We're going to move on. Volume of a cylinder. Let's use our imagination. Ooh, these are actually so useful. This is my top of it. So volume of a cylinder. This is a cylinder. Okay. So volume refers to how much something a solid can hold, how much it takes to fill it up, or how much space it takes up. You are a 3D figure, right? So if you want to, I like to give this example for volume. When you were a little kid, when you got old enough to run your own baths, because little kids take baths until they reach a certain age. I don't remember what that age is, but you fill the tub up, and then when you get in it, what happens to the water level? It goes up. Did you ever fill it up too high, and then you sit in it, and either almost overflows or it overflows? Because your body takes up space in that water, right? So you are taking up the space that that water was in before. So volume is how much a solid will hold or how much space it takes up. That's not an exact definition, but it's a practical one. We just want to know what we're finding when we say we're finding the volume. That's what we're finding. And the formula for the volume of a cylinder, so if you look on your reference sheet, this is what you see. But you have to remember that that big B is the area of the base, right? So big B is actually pi r squared for a cylinder. Because the shape of the base is a circle, this is the formula for the area of a circle. So the volume formula for a cylinder is modified to pi r squared times the height. So pi times the radius squared times the height, because this is the same as that for a cylinder. Oh, dude, you're right. Thank you. You don't have to write those in. So whether you're finding the volume of a right cylinder or an oblique cylinder, it's the same formula. You're still finding the circle, the area of a base, and you're multiplying it by the height of the cylinder. Make sense? area. Sometimes you're going to be asked to find the surface area, sometimes you're going to be asked to find both. I'm going to tell you how I want you to find it so we're rounding to the same thing, okay? So first off, lateral area. What do we say the formula for the lateral area of a cylinder is? Pardon? 2 pi r h, right? So 2 times pi times radius times the height. So I'd like for you to write the formula, but you must, to get credit for a problem, you must plug in for the formula. So I must see 2 times 3.14 per pi. Wait, is this the radius or the diameter? Yeah, this is, if it draws a line across like that, it's a diameter. So the radius is 4. Alright, so 3.14, okay, 2 times pi, 3.14, times the radius, which is 4, times the height. This is the height of the cylinder. So if we're just finding the lateral area, we're going to round to the 10th place. If we're finding the surface area, we're not going to round there. We're going to put everything in and then put it in our calculator all at once. All right, I got 411.968. Is that what y'all got? All right, 411.968. We're rounding the 10th place. That's going to round to 412. Has the letter A in it for area, so it's a square unit of measure. The lateral area, remember, that's a flat thing, two-dimensional. All right, are you with me? So we're finding the surface area. Right, 2B plus pH, right? But we modified that for the cylinder. So 2B is 2 pi r squared plus pH, which is 2 pi r h. That's the P, right? Make sense? Especially for the surface area, I would highly recommend you write this formula and then plug in right below it, and that'll help you keep yourself organized. Because that is half the battle. So the surface area equals 2 times, we're going to use 3.14 per pi, times the radius squared, so the radius is 4, plus, so the 2, the pi, the radius, because you can kind of see exactly where they go then, plus 2 times pi, which we're using 3.14, times the radius of 4, times the height of 16.4. You may be tempted, and sometimes different problems will tell you to do it differently, you may be tempted to find 2B, find the lateral area, and then add them together, and that is an approximation, but we want to be a little bit more precise than that. So when we're finding the lateral area, or given the lateral area, we're going to do pH and round to the 10th place. Right, in this case, pH 2 pi RH. But when we are finding the surface area, we're going to plug all of this in on our calculator at once. So everybody clear your calculator out and start plugging it in. We need to all be able to make sure we can enter it on our calculator. So it's 2 times 3.14 times 4 x squared button plus 2 times 3.14 times 4 times 16.4. And I got 512.448. Is that what you got? Is that what you got, Wendy? Did you do it? Okay, I want you to practice it on the calculator. Is that what you got, John Luke? You didn't do it. Anybody do it? Is that what you got, Anaya? Sorry? All right, 512.448, let's get around. Now we're going to round here at the end. It's going to be 512.448, so it's point 0.4. So 512.4 meters, once again, it's area, so it's a square unit of measure. This can be very tedious. It lends itself to making lots of mistakes. So you got to use strategies to try to keep from doing that. So I would suggest write your formula and then plug in right below it. Last but not least, the volume formula, where it's area of the base times the height, but when we modify that for a cylinder, area of the base is pi r squared times the height. So pi r squared h. Yes, so this is big B, this is h. Right? So the volume formula is capital B times h. Remember what big B, it stands for the area of the base. Since our base is a circle, we substitute the big B with pi r squared, because that's the formula for the area of a circle. If we were finding the surface area of a rectangular prism, we would substitute to the area of a rectangle, or of that base, so length times width, right? If we were finding the surface area of a triangular prism, the bases of a triangular prism are triangles. So we found the area of the base of a triangle would be base times height divided by 2. Tricky thing is, it's not the height of the cylinder, it's the height of the triangle, right? We found the area of the triangle before. Yes. So for each different solid, each of these different solids has a different shaped base. So each of these different solids is going to have a different, it's being modified differently. So if the base is a circle, big B is pi r squared. If the base is a rectangle, it's length times width. If the base is a triangle, it's base times height divided by 2 of that triangular base, right? So good question. Defining the volume. Now the volume, we're going to use 3.14 for pi. The radius, remember, is 4, not 8. And the height is 16.4. Now, volume is a cubic measure. Remember, it's not just length times width, it's also depth. So, length times width times height is one way we will see it when we get to rectangular prisms. So, let's say on our calculator, 3.14 times 4x squared button times 16.4, and I got 1611.136. Is that what y'all got? All right, let me clear my calculator out. 3.14 times 4x squared times 16.4. 823.936? Okay. 823.9 then, because we rounded to the 10th place. 823.9, and it's meters cubed. Volume is a cubic measure. It's got 3 dimensions. Area is 2D. It has 2 dimensions. It gets an exponent of 2. So we're going to do example 6 a little bit quicker. What is the radius for example 6? What's the radius? 15, right here, right? This is the radius from the center to a point of the circle. And this is the height, right? That is the same distance as from here to here. So, if it's a right cylinder, you can do the height here to here, or from the center to here. Sometimes I will do it. They're the same. Alright, so we're finding the lateral area. 2 pi r h. 2 times pi times the radius times the height. 2 pi r h. Once again, if you're finding that confusing, you can just write 2 pi r h and then substitute right below it. That might be less confusing. so you can see as you go, right? And we'll see if you got your guys on that phone. What'd you get? 235? No. You got any Dalton? 2355? 2,355. Will you go put it on my keyboard, Bella? Okay. So this is 2,355 square feet in this area. Definitely on this one, I would write this formula and then plug in right below. This really long one, the surface area is a really long one. So go ahead and write your formula you're plugging into. Now, once again, I'm not going to take off if you don't do this part. But if you don't do this part, you will not get credit for a problem. Okay? They're very clear on that. You can go online and find the answer to any of these kind of problems. See, you're going to see, wait. Keep your hand off your head, or head off your hand right on your might have to be easier. Alright, so now we're going to plug in. It stays the same. Pi is 3.14. The radius we said is 15. We're squaring that. Plus 2 times pi, which we're using 3.14 unless they tell us differently, times the radius, which is 15, times the height of 25. We're going to do that on our calculator. So for the lateral area, when you're finding just that, you rounded it this way. For the surface area, you're plugging everything in, and we're going to work it straight across from left to right on our calculator. 2 times 3.14 times 15 squared plus 2 times 3.14 times 15 times 25. I got 3768. Is that what y'all got? Mm-hmm. Thank you. Who do you want me to send the other part of that question? Ms. Giglio? Which classroom will you be in when you take the other part? Who's the teacher in there? Mr. Gannat? I'll send it to Ms. Giglio and then she can do it to Khadijah. Okay. Alright, and what's the unit of measure here? Feet squared, that's right. Alright, and last but not least, volume is the easiest one. Pi r squared h, pi r squared h, plug in 3.14 for pi. The radius is 15, so 15 squared times the height of 25. Pi, radius, height. And I got 17.25. We're going to round that to 3, and that's cubic feet. Come on. Oh, my bad. Yeah, you're right. I was thinking I don't remember getting that earlier in the day. It's 17,662.5. Jaden, honey. You need to take some initiative. If you have a hard time falling asleep, you can use my standing desk, okay? I'm staying awake. All right, y'all caught up with me? One more. Okay. What kind of cylinder is this? Oblique, right? This is not the height. It doesn't really matter in this example because they didn't give you this length, so you're not tempted to use that length. They only gave you this height, so the distance, if this was sitting on the ground, one way to think about the height of a prism or a cylinder is how tall would it be if it was sitting on one of its bases. So you would not measure from here to here, right? You'd measure from here to here. So the radius is 15, and this is the height. So the volume is still area of the base times the height. It always is, with area of the base, pi r squared, then times the height of the cylinder. So this cylinder has a radius of 15 and a height of 25. Our last example also had a radius of 15 and a height of 25. One's a right cylinder, one's an oblique. Let's see if it's the same. So 3.14 times the radius, 15 squared, times the height of 25. And it would, if you plug that in your calculator, obviously we're plugging in the same thing, you're going to get the same answer. If you look at number 11 on your worksheet, asking you to find the height, but they are giving you the volume, so you're going to plug the volume in here, so you don't have to write this, but for number 11, you're going to use this formula. You're going to plug in here, and plug in, so this would be, my bad, let me redo this. This is the number 11. So it would be pi r squared h. So you're going to plug in the volume because they tell you that, and you're going to plug in for the radius because they tell you that, and then you're solving for h. Is that number 11? 11. Okay, number 11 is a different one. That was for number 12. That was for number 12, not B. Number 11, you'll see they give you the diameter, and they give you a diagonal, but they don't give you the height. So you're going to use the Pythagorean theorem, right, in number 11? Does that make sense? The diameter is going to be one leg, the height is a leg, and the diagonal is your hypotenuse. Because they don't give you the height, you have to find the height before you can plug in. On number 11, not number 12. Number 11, you need the Pythagorean theorem to find the height. That's a right angle right there. Yeah. So this is actually a hint for number 12. The hint for number 11 is you got to use the Pythagorean theorem to find the height. And then you plug in the formula.